Welcome back, grade 12s. Now we are starting again a series of videos, part 1 and part 2. But now we are going to look now at the electrolytic cell, and we are going to look at questions where you are required now to calculate the current flowing through the cell itself. So I think I'm going to do part 1 and part 2 on these questions. So this is part 1 now. So we are looking at the electrolytic, but we want to calculate the current. So we are only going to look at that question. I'm not going to go and do the whole entire question. So I have a question in front of me. Yeah, this is a November question. I forgot the year, but there was a question where a learner was required to calculate the average current. Now let's read the statement and then we'll see the question. The statement says, high purity copper is obtained by electrolysis using a thin pure copper cathode and an acidified solution of copper 2 sulfate. Then this is the diagram that they gave us. This is an electrolytic cell, as you can see. Then there is a graph on the right that is showing a relationship between the mass of copper deposited and the amount of current. So you can see that the gradient is positive, is increasing. That means that the current is directly proportional to the rate of the mass of copper deposited. And then the statement says, when a constant current flows for 1 hour, 32 grams of copper, of pure copper, is deposited at one of the electrodes. Determine the average current required to deposit 32 grams of copper. Yeah, now this is the question that I want us to focus at. And this question, by the way, is like plus minus 7 marks. The number of marks is 7 or 8, I'm not sure, somewhere there. So let me explain what's going on here and how we are going to be able to calculate that current. So previously we know that one of the electrode is pure copper and one is impure copper. The shorter side of the electrode of the battery, the pole of the battery is negative, making this one negative. So the other side is longer, is positive. It makes the electrode A positive. So electrode B is negatively charged, so we know it's going to attract positive ions from the solution. So we call this one, the negative one, the cathode. And then this one, electrode A, is going to attract negative ions, and we know this one is going to be called anode. And the impure copper is always on the anode. And then the pure copper, that will be our final product, will be on the cathode. That's what we know. Now inside the solution, the electrolyte, we have a copper sulfate solution. But if you look at the statement up there, they said the solution is of copper 2 sulfate. That means that solution is copper 2 sulfate. It looks something like that, such that if you break this down, it's gonna look like this. So this is a solution that we have here. It's a copper 2 sulfate. So imagine there are copper ions that will come from the anode. Remember, on the anode we have the oxidation. That means we have a loss of electrons. Electrons will be coming that side, and it's going to lose also copper 2 plus ions. That will be reduced now on the which will be reduced on the cathode, which will be reduced on the cathode. So the cathode is going to receive now those electrons and becomes a pure copper in a solid form. So that's how purification of copper or refining of copper takes place. This side we know it's a reduction. So that side is reduction, the other side is oxidation. This side is a gain of electrons. Now, they said here now, when a constant current flows for 1 hour, 32 grams of pure copper is deposited at one of the electrodes, which means at the cathode. So the mass of copper that will be deposited at this one, this will be a very pure copper. The mass of this copper, they said, is 32. The mass here is 32 grams. That is a 32 gram mass as the current is flowing. So the question now is saying determine the average current required to deposit 32 grams of copper. So we want to know now the average current that must flow. Remember, what is current by definition? Current is the rate of flow of charge. That is the definition of current. So there is charge that is moving through through the battery. That's how oxidation, that's how reduction takes place at the cathode. So I want to show you now how to calculate this average current. There are plus minus 5 calculations that we are going to do to arrive at the answer. So let's do it now. Okay, this is the information that we have. The solution there is copper 2 sulfate, and the mass of copper deposited is 32 grams, and you want to know the average current flowing through. So the first thing that you must do here, you must now check the ratio as the copper 2 ions are being reduced now to become the pure copper in a solid form. Remember, current, what is current? Current is the rate of flow of charge. This is current. This is the formula for the current. Current is the rate of flow of charge. So this one is a reduction is happening at the cathode. But on the anode we have copper oxidized. This is the oxidation reaction. So as these electrons are moving, we know that current is flowing, because immediately when a bulk of electrons moves, that bulk of electrons moving, we call it a charge, and as the charge moves at a certain rate, that will be called a current. So the first thing that we need to find out now, we need to find now what is the amount of charge flowing. Now, how to find charge? So we need to check now on our equations. I think paper 1, this formula is coming from a paper 1 data sheet. You won't get it on paper 2, by the way. So let me show you now the formula to get the amount of charge. Okay, look at this. Now, these are the paper 1 formulas, but we are answering a paper 2 question. That means that you need to know these formulas, the ones that I'm going to show you, in order for you to be able to answer that question. So I'm saying the first formula that you need to know is this one. This is the formula for current. As you can see, it says I is equals to Q over delta T. This is formula number 1. So the question is how to get this amount of charge. Now the amount of charge, let's say this is formula number 1. This is the formula for the charge that you must know. It's also on paper 1. Here is charge. So this is formula number 2 that you have to use in order for you to get the charge here. But this formula for the charge says N is equal to Q over E. What is this N stands for? What does this E stands for? Now the E you can see here, the E is the amount, or is the charge on the electron, or is called the quantization of charge. It has that value. But what does the N stands for? Now this N is the number of electrons, or is the number of particles. In other words, the charge is equals to the number of particles multiplied by the quantization of charge. So this N is the number of particles, or the number of electrons. But how to find the number of electrons? The number of electrons, because to find Q, you need to know how to find N. Because we know the quantization of charge is 1.6 times 10 to the negative 19 coulomb. So to find N, we use this formula now. It says N is equal to N over Na. So this small n that you see here is actually the number of moles of the electron. Number of moles of the electrons, which is equals to this capital letter N, which is the number of particles. This is the number of particles or electrons. Particles or electrons, and then is divided by the Avogadro's number. So this now becomes the third formula. Okay, now this one is just formula number 3. So the challenge here is that this N that you see there is exactly the same N that you see there. It's just that this formula is a grade 10 formula. So this one is a grade 12 formula. But I wanted to put them in the same page so that you can see the continuity, the flow, the continuity of knowledge here. So I'm saying to you, after now we managed to get now this, remember we said we need the amount of charge. Why we need the amount of charge? Because we want to find the current. The current wants to first find the amount of charge flowing, divide by time. They told us the time. They said the time is 1 hour. So remember, time must be in seconds. So 1 hour in seconds will be there are 60 minutes in 1 hour. So in seconds we have to multiply again by 60, which will get 3,600 seconds. So we already know the time. But what we need now, we need the charge. How to find the charge? To find the charge, you must first go and find the number of particles or number of electrons. We multiply the number of electrons by the amount of charge on the electron. But how to find N? I'm saying to you now, you need formula number 3. This is what now we need to find, the number of particles. So to find the number of particles, we need the number of moles of the electron, because we know the Avogadro's number. The Avogadro's number, we know it is Na it is Na is equals to 6,022 times 10 to the power 23 particles. So that is the Avogadro's number. They say that 1 mole of a substance is equals to this number of particles. So the question is, we want to find the number of particles, but what is the number of moles? So we need another formula now. The number of moles of the electron is equal to, you remember, let me not confuse you now. Go back here. I want to show you something. The 32, the mass that you see here, this 32, this is the mass of the copper. This is the mass of the copper. This is the mass of the copper. In other words, this is the mass of this. This is the mass of this. This is 32 grams. You can find the number of mole of this copper by saying mass of the copper divided by the molar mass. But how do you find now the number of moles of this electron? So what you need to do here, you need to just use your ratio. What is the ratio between the copper and the electrons? The ratio here is 1:2. You have the copper, you have 2 electrons. So the ratio here you can see is 1 of the copper provides 2 of the electrons. So if we know the number of moles of the copper, then we can know the number of moles of the electron. So we want to find the number of moles of the electron. That's what I'm saying here. We want to find the number of moles of the electron. We want to find the number of moles of the electron so that we can substitute it here. The number of moles of the electrons multiplied by the Avogadro's number will give us the capital letter N, which is the number of particles. And then we will take this number of particles, we will substitute it here to find the amount of charge. Then we'll take the charge, we'll substitute it here. Then we get the current. So I'm going to do this step by step. So I'm saying the number of this is the ratio between the copper and the electron. So that means we need to go and find first the number of moles of the copper. This is the formula that we are going to use. So this is formula number, is it formula number 4? I think. Okay. This would be 4, but to find the number of moles of copper, this would be a calculation, a 5th calculation. So I think I have shown you the map here. So we are going to move now from backwards. So we're going to start with calculation number 5. From calculation number 5, we find the number of moles of the copper. We know the mass is 32. We use the periodic table to find the molar mass of the copper. When we get the number of moles of the copper, we're going to substitute it here. And we're going to check the ratio. Remember, what is the ratio? 1 of this is to 2 of that. So the number of moles that we get from calculation number 5 is going to give us the number of moles, which will multiply it by 2. Then we get the number of moles of the electrons, which is, this is the 4th calculation. This is a 2nd calculation, which is calculation number 4. Then we move to calculation number 3, because we now have the number of moles of the electron. So we do have this now. We want to find the number of particles or the number of electrons. So we multiply those number of moles that we got from calculation number 4 by the Avogadro's number, which is 6,022 times 10 to the power 23, then we get the number of particles or the number of electrons. Then we move to calculation number 2. Now we know the number of particles. Remember I said this n, this small n is just a confusion in grade 12. In grade 12 is confusing us, otherwise they were supposed to say capital letter N because of it's the same thing. After we get now the amount of charge by taking the number of particles, we multiplied by the amount of charge on the electron, which is 1.6 times 10 to the power negative 19 coulombs. We take now this amount of charge to formula number 1. This is Q now, divide by the time. Then that would be our current. So that's what we have to do to find the current. Because the question is saying, determine the average current required to deposit 32 grams of copper. So I guess now you can see why it's around 7 or 8 marks. Because there's a lot of calculations. There are like 5 calculations that we have to go through. So let us do it. Okay, so we are gonna start here. Okay, we start by formula number 5, which is say the number of moles of the copper is equal to the mass of the copper deposited divided by the molar mass. Now the mass is said to be 32 grams over, what is the molar mass of the copper? Okay, on the periodic table, the molar mass of the copper, as you can see, is 63,5. So that is the amount of the molar mass. So we divide here by 63, divide by 63,5. So let's quickly get this. 32 divide by 63,5. So we get the number of moles to be 0,504. 0,504. 0,504 moles. These are the moles of the copper. So now we need to find the number of moles of the electron, because we are dealing with current, and current deals with charge, and charge deals with electrons. What is the ratio between the copper and the electron? 1:2. So if we know the number of moles of the copper, then we can know the number of moles of the electrons. So we find this to be 0,504. That means the ones for electrons must be 2 times that of the copper. So we need to multiply now. So this is the number of moles of the electron. 2 times that. Multiply that by 2. Then we get 1,008. So the number of moles of the electron is 1,008. 1,008. Yeah, so the number of moles of the electron is 1,008. So now we move to formula number 3. So we say now we want to find the number of particles or electrons. Particles or electrons, we said is equal to the number of moles, which we just calculated, the number of moles multiplied now by the Avogadro's number. So the number of moles there is 1,008 multiplied by the Avogadro's number, which is 6,02, 2 times 10 to the power 23. So we want to find the number of electrons now. which is that multiply that by 6,022 to the exponent of 23. So we get the number of particles, which is something like 6,0694. All of that number, but I'm just gonna write 6,094 times 10 to the power 23. It's to the power 23. Yes, to the power 23. Now after this one, now we want to find the amount of charge. The amount of charge, we said now it is the number of particles. I'm gonna say it is the number of particles or number of electrons. It's the same thing. Multiply now by the amount of charge of electrons. I hope this makes sense. So now I'm taking now this amount of particles, and then I'm going to multiply it by the amount of charge on the particle, which is 1.6 times 10 to the power negative 19. This is in coulombs, so the answer will be in coulombs. So I multiply this now by 1.6 to the power of negative 19. So I get something like 97,110,67. 97,110,677 charge. So this is the amount of charge. Now I want to find now the average current. The average current then would be I is equals to the amount of charge divided now by the rate of time. Divide by the rate itself, by the time it takes for this charge to flow. So it's going to be now that 97,110,677 divide now by the, remember the time is 1 hour, but you must convert it to seconds. So this is coulombs, this is seconds. So this will get us, divide that by 3,600. Then we get something like 26,98. 26. Now we take 2 decimals at the final answer. 26,98 amps. So this is the average current that will flow through. So there are up to like 5 calculations that you have to do throughout. So let me recap before we move on to part 2. So we are saying the first thing that you have to do, go find the number of moles of the copper. After you find the number of moles of the copper, check your ratio, and then go find the number of moles of the electrons. Suppose the ratio is 1:2. After you get the number of moles of the electron, go find now the number of electrons themselves. We use this formula. The number of electrons would be this number of moles times the Avogadro's number. This is the number of electrons or particles. Now after you got the number of electrons, then you go find the amount of charge. Because the amount of charge is the number of electrons multiplied by the amount of charge on each electron. So this is calculation number 4. After you get now your amount of charge, Then the final calculation then will be, go now find the average current. Then that would be your final answer. Yeah, that's how we do this question. So you might find this thing on your exam, so you must be able to find this average current. I'll do another question on this average current in part 2. So I will see you now on part 2 on our videos calculating the current of the cell.